artificial intelligence, supercomputers, electric vehicles, and smartphones. Every technology breakthrough shaping our future depends on one thing: semiconductors. And when the world needs the most advanced chips, one place sits at the center of the supply chain: Taiwan. But Taiwan was never destined to become the heart of the semiconductor industry. 50 years ago, few people would have predicted that an island with a population of 23 million people would become indispensable to the world's most advanced technologies. Today, we trace the story behind Taiwan's semiconductor rise and explore how that advantage is evolving in the age of AI. I'm Laurel Stewart. This is The Chainmaker. 3 points we'll be covering in today's episode: how a small island engineered a global giant, why ecosystems matter more than a single company, and can Taiwan maintain its edge? Artificial intelligence has thrust semiconductors into the global spotlight, but Taiwan's journey began long before the AI era. Over the decades, a small island built one of the world's most sophisticated technology ecosystems, transforming itself into a linchpin of the global economy. Joining us today is Dr. Konrad Young. He's a former R&D director at TSMC and one of the most respected voices in the semiconductor industry. He's now the executive director of the Innovation College at National Taiwan University of Science and Technology. Welcome to the show.
Thank you, Laurel. It's my honor to be here.
I'd like to start with Taiwan's semiconductor dominance.
Sure.
Back in the early days, this was a success that wasn't necessarily guaranteed. When you tell Taiwan's semiconductor story, where does it begin for you?
Well, I personally come to Taiwan in 1995. I consider that's the golden timing. Most of semiconductor company go on public IPO in 94. So they have enough, they use the stock market to give the overseas returnee the compensation so that we working in US in semiconductor industry can come back without too much sacrifice of our salary. Before that, the salary is only maybe 10% of entire compensation.
And back then, did you anticipate that Taiwan would become the epicenter of the semiconductor industry?
I would say absolutely no. Okay. In fact, when I first come back to Taiwan in 1995, Taiwan technology is far behind from US. The semiconductor industry started in US roughly in 50 and 60. And they have been dominated. In 80, Japan rise up and then going down quickly. So and later, Korean come out with DRAM. So Taiwan is in a catch-up mode for a long period of time. Yeah.
So what was it that really propelled it forward in that period?
I think the first period is we call ITRI time, Industrial Research Institute. It started established in 1973, and then also 74. And then so-called we have a project called RCA project, transfer technology from very old technology from US RCA company. But that's just started. That technology doesn't go much well because it's too old. The value is not very good. But it provides the foundation for Taiwan in Hsinchu, near Hsinchu Science Park, to incubate the local talent. Actually, ITRI I consider is the first phase of talent incubation because the school doesn't know how to teach semiconductor in most of the college.
So how did ITRI work with policymakers and academia? How did that all fit together?
In fact, I don't think ITRI worked with too much on academia during the time. Taiwan academia was too far off. What ITRI definitely is incubated by government. I think there are two leaders, KTD, and then Mr. Sun, Dr. Sun. So they provide this policy, try to focus on semiconductor. And in 74, in 73, they start ITRI, and in 1980, they start Science Park. These are all preparing for the future. And it's only the initial phase of semiconductor foundation. And the school pretty much only teach the normal class, physics, chemistry, and so on. And most of the people, I graduated in 1981, was major in semiconductor, but I have no idea what Taiwan is trying to do. So after I finished my college, I went to US. At that time, we have a slogan called come to NTU, National Taiwan University, then go to US.
Okay.
Okay. Majority of my classmates, more than 80%, went to US to study graduate school. So the talent development is two parts. One is after college, some people went to ITRI, a relatively small part of it, but majority of talent actually went to US. Working in semiconductor major league in US. We are in the best company in the world. So we're trained to be the World Series leader. You can play the global game. Yeah.
During that period, with so many students going to the US, what was it that made policymakers then put their bets on Taiwan developing its domestic industry?
At that time, what Taiwan industry was, local industry tried to do is preparing the environment so that the people from US can come back. I had to say it's very tough. ITRI started 74, UMC spin off in 1980, and then the TSMC spin off in 1987. And during that time, I was recruited by those companies, but I have no way to come back. Most of people, a few people come back and then leave almost quickly because they couldn't get enough compensation and work extremely hard and cannot get enough result. Only until 1994, the stock market explode. And then they can afford, they can give us a free stock as a compensation so that we can afford to come back to Taiwan. So 1994 and 95 is a period, is a peak period of semiconductor returnee from US, original from Taiwan.
And when did you have a moment where you realized that Taiwan would be successful?
During the time, especially in the middle of 90, the manufacturing, I sense that the manufacturing, there's a wind flow from US back to the Far Eastern region. And Asian has a more DNA to do manufacturing compared to most
What do you
Western
mean by
people.
that?
Well, DNA, what I mean is they tend to be work extremely hard. They don't complain much. They have a slavery mentality, willing to work overtime, and to focus on certain things. They are very good. So actually, relatively speaking, I think Western country, including Europe and the US, initially after the Second World War, they might has a chance to do that. But when they are getting to the prosperous time, in 1990, there are so many things happening, starting from PC, then later internet. There are too many opportunities for American people. So manufacturing is considered a blue-collar worker. So that's why, and only Asian, even back to 1980, when we were in U.S. semiconductor industry, we joke, it called IC industry, integrated circuit, but we actually joke it as Indian Chinese industry, because most of workers in U.S. are foreigner and pretty much Asian. Every country has its own strengths and weakness, and Taiwan, in general, the condition was actually started even back to the 1960s when we have an export zone, export economic zone in Kaohsiung, back to that time. You know, when I was young, my family, my parents actually put some job back to the home. We are making some kind of Christmas light, Christmas card. The family is a factory. We actually call that family factory era during 1960. And I grew up as a primary school student. I'm so used to it.
So it all kind of stems from that basis.
Yeah. The foundation is that kind of willing to work hard, even with a low income.
Whenever the world talks about Taiwan's semiconductor industry, one name dominates the conversation, TSMC. But no company succeeds alone. Behind every chip is a complex network of suppliers, designers, engineers, equipment providers, researchers, and manufacturers. This extensive network is where Taiwan's competitive edge resides. So I'm curious, is there any misconception that people have when they think about Taiwan's success in the semiconductor industry?
The ecosystem established normally, naturally, because ecosystem is a biological term. In the semiconductor ecosystem, it started from the downstream, the design, the product area, and also manufacturing, the equipment, the material to supply the whole chain. Taiwan is focused on the manufacturing side. When the manufacturing is getting bigger and bigger, TSMC started from a very small company doing foundry, then gradually become so big. And we start the business demand. Equipment supplier will come to Taiwan. ASML, applied material, they will naturally come to Taiwan because this is where the business really is, and you need a local support because hardware is not like a software. You can do online do activity. And the design side, even though the design company most are still US, but Taiwan has some design company catch up with the kind of second tier product. And MediaTek benefit from China's cellular phone market, which is not US market anymore. We have some China market also bring the design company to Taiwan. So ecosystem kind of developed naturally. TSMC was a relatively small company, even in 1990. I think they start to go into the top 5 probably around middle of 2000 or late 2000. Okay, TSMC benefit from each era. In 1980 and 90, it was a PC, personal computer. Okay, Intel dominated, but there are so many designs to support Intel. And manufacturing just focus on PC product. And in 2000, Internet come up. Okay, so Internet dominate the new product, and Broadcom actually dominate that market. And roughly about 2006, 2005, the cellular phone rise up, and Qualcomm start to dominate, and later Apple dominate. So starting from PC to Internet to mobile cellular phone to today's AI, we really don't care what era it becomes. Because
they're part of all of it.
Because they need a semiconductor to support that. So we are serving all the things, not just a product. It's a foundation to make everybody successful. And that's the beauty of foundry.
So I'm curious because it sounds like a very natural progression, development of this ecosystem. But other countries have also been spending billions of dollars building fabs themselves, but haven't been able to establish the same ecosystem that Taiwan has. Why is that?
Actually, the building the fab is a mostly business decision. TSMC built a fab because of there's a market need, and we want to get business. We have a demand, so we build a fab, and we calculate the cost, so we still benefit for that. And I mentioned since there are different needs as time goes. a lot of country, if they want to use the government subsidy to do that, that's actually pretty bad investment, because the subsidy, it cannot be forever. You need to have at least a business to carry year by year. The best investment typically is in the beginning when there's a rising. When it's getting to the mature phase, the money you spend too is very quickly dilute because it's so huge investment, just a fab today. Yeah, so just money spending is not very helpful. Including like Samsung, the Korean, they might have some government help, but they definitely have their DRAM market need. China could be a really unusual situation, but China today also already have their enough market to drive it. So I still consider market is a dominant driver, not the government spending subsidy.
So if TSMC was established in a different country, would it be a totally different company?
If the industry has all the kind of ecosystem, the natural things with a talent, TSMC will naturally be successful. Yeah.
This is the very ecosystem that enabled Taiwan to dominate an era of computing. Now, AI is rewriting the rules of the game. The question is no longer just about shrinking transistors, but also how entire systems are designed, integrated, and deployed on an unprecedented scale. You mentioned that you've obviously worked through multiple waves of different technological advances. How is the AI era changing the semiconductor industry?
It is first on the business side. You start to see the demand, the money spent. The top 7 company in the world spend tons of money just try to create computation power. Traditionally, for a company like TSMC, we are doing the so-called SoC, silicon on chips. Okay, system on chip basically is a single chip product, but AI need a lot more function than one chips. Okay, that's why it fundamentally changed the demand of technology. Okay, that's why the recent one called advanced packages start to play, because you need more than just one chip. You can put many chips together, including memory, including many things all together. TSMC actually do an advanced chip, I would say accidentally. In roughly about 2011, there's one person, ITRI's chairman called Nicky Lu. He proposed that advanced packaging idea, so-called heterogeneous integration, to TSMC. Since then, TSMC has worked in the underground. Okay, we don't really have any business at all. From 2011 all the way almost to 2020, for many years, we don't have a business for that. And actually, as I remember, Morris was very angry with that project because it's a return on investment. I invest something doing certain things, and initially only the product like Apple or Xilinx use it a little bit, but AI really has a strong demand for that. So TSMC prepared 10 years, almost no good business. And when the timing is up, and it start to play the important role of advanced technology, I would say, is that what we expected? Absolutely no. I mentioned for the first 10 years, within internal review, it's a bad project. When AI really coming up, we naturally took it to AI, working with NVIDIA, AMD, and so on. I would say TSMC is really lucky, or Taiwan is really lucky. I put it, it's really blessed by God to have to do almost everything right.
Do you think Taiwan faces any risks in the next 10 years?
As long as there is a silicon technology, including advanced packaging, still going on, it's very hard for a lot of people to catch up with TSMC, for example. The only risk, the biggest risk for Taiwan is the war. If really there's a war, like a Second World War, happening in Taiwan, it's gone.
Yeah.
Pretty much gone. So hopefully there's no war for that. But the secondary risk, I call it the geopolitics issue. The TSMC was forced to go to US. It has a good or bad. It's not just a bad thing. Sometimes there are good things.
Are you referring to the TSMC investments in Arizona?
Yeah, Arizona. Yeah. TSMC, if there's a choice, TSMC will not go to Arizona. Okay, because we had experience in U.S. Manufacturing before in Washington State. That fab was not very successful. TSMC really doesn't know how to run a U.S. fab, okay, relative to Taiwan. In Taiwan, we took advantage of everything Taiwan provides. When we leave Taiwan, everything else becomes second tier kind of support. So, but anyway, TSMC was forced by U.S. Because of national security, critical infrastructure, demand. So I don't think TSMC has any choice for that. Okay.
So you think the most recent investments from TSMC in Arizona, the expansion of manufacturing in the U.S., was forced?
It was original force. But actually, because the demand is so high right now, all the chip demand is so high, right? So TSMC cannot afford to build everything in Taiwan. Taiwan doesn't have enough natural resource and also people maybe. Okay, but so since we have to go to U.S., we might as well to take advantage of that to learn how to work in U.S. environment. I think it's a challenge, but it's also opportunity. Okay, I say initially was forced to go, but since you have to go there, you just try to take advantage of everything. Yeah.
Finally, I'm curious, what would you give as advice for the next generation of engineers in Taiwan in this industry?
Semiconductor industry is no doubt the so-called tier one industry. It's very hard to find another tier one industry to replace semiconductor. The reason why semiconductor is such a good industry because it's global market. It's major league play game. So the salary tend to be very high. If you want to go to semiconductor industry, you still need to know who you are, your role in semiconductor industry. Because if you don't just be a small potato, small worker, it's not going to be satisfactory career. So dig into your own strengths, your own passion. Think about what with that kind of strength, what you can provide to help the semiconductor industry. The AI definitely changes everything, especially learning the knowledge part. So it becomes relatively easy to understand whatever the knowledge is. But your personality, your character is getting a lot more important. So that's why in school, during this period of time, I'm more focused on develop the students' character. I try to develop the three inter-skill, talent, inter-discipline, inter-cultural, inter-generational skill. So with that kind of skill, you are facing anything change, because even semiconductor will have some change as time goes. Yeah, so you need to adjust to whatever the new market is.
That's really refreshing to hear. Yeah. Thank you so much, Dr. Young, for joining us on the show today.
Sure. Thank you, Laura.
Taiwan's semiconductor leadership wasn't attained overnight. As we've discussed today, it's the result of decades of investment in research, manufacturing, talent, and collaboration across an entire ecosystem. Stay with us. Up next, the Supply Chain Index. AI is already reshaping the semiconductor industry. The global chip market is projected to surpass $1.5 trillion in 2026, driven largely by strong demand for memory and AI infrastructure, and continue growing towards $1.9 trillion in 2027. The message is clear: semiconductor demand remains strong. And for one final story from the world of technology and business, here's TechBiz. SK Hynix has approved a $38 billion investment to expand semiconductor production in South Korea. The move is aimed at supporting growing demand for advanced memory chips used in AI systems. It highlights one key reality: AI growth depends not only on processors, but also on the memory technologies that keep massive AI workloads running efficiently. Nearly 20,000 new jobs have been linked to AI data center construction across the United States. The trend underscores that AI is not just software. It also requires power, facilities, cooling systems, and the workers who build and operate them. That's all for today's Tech Biz. From the emergence of the foundry model to the establishment of one of the world's most comprehensive semiconductor ecosystems, Taiwan has developed capabilities that now underpin the global digital economy. As AI generates new demands across the supply chain, Taiwan's next chapter may be just beginning. Thank you for watching The Chainmaker. I'm Laurel Stewart. We'll see you next time.